you've been really involved with the NCSEA AI grant team, and you'll be presenting at both the pre-conference and closing keynote at the upcoming summit in New York, which is October 14th through 17th. You've also recently joined the NSF IUCRC VISER Center, which is focused on AI and structural engineering. Can you just give us a little bit of background on what all those letters mean? And then can you share how those experiences are shaping your perspective on the role of AI in the future of structural engineering and then project delivery?
AI and process automation is really the future of many fields, but engineering is going to be one of them. Will AI replace SEs or structural engineers?
What if artificial intelligence could help structural engineers design smarter, faster, and with fewer errors starting today? In this episode of the AEC AI and Tech Strategy podcast, we're getting answers to that question with Jesse Light, SE, PE, and President/Senior Structural Engineer at SML, Consulting Structural and Forensic Engineers. Jesse will speak about how AI is already transforming structural design, where it brings the most value in daily workflows, and what it takes to bridge the gap between traditional engineering and emerging technology. We'll also cover the biggest barriers still holding firms back and what leaders can do to overcome them. If you're an engineer or AEC decision maker looking to stay ahead of the curve, you will not want to miss this conversation. But before we jump in, I wanted to tell you about our AEC PM Connect event, built for project managers who want to improve project delivery, communication, and leadership through practical sessions and tools. These events provide an avenue to connect with leading PMs in the industry. Visit aecpmconnect.com and register today. We currently have events in Kansas City and New Jersey, with more coming, and I hope to see you there in person. I would also like to recognize one of our sponsors for the event, Trinovate Advisors. Trinovate Advisors is a consulting partner dedicated to transforming architecture, engineering, and construction firms through a human-centered approach to innovation. By working closely with firm leaders, Trinovate helps uncover the strengths of their people, refine the business processes, and strategically adopt modern technologies that fuel clarity, efficiency, and sustainable growth. Beyond organizational strategy, through honest assessments and tailored guidance, Trinovate empowers entrepreneurs and firm leaders to navigate challenges, strengthen confidence, and achieve alignment across every aspect of their journey. Visit trinovate.ai to learn more. Now it's time for our conversation of the week with Jesse Light. Jesse, welcome to the show, and thank you so much for taking the time to join us.
Thanks for having me, Nick. Appreciate being here.
Absolutely. So Jesse's got a really interesting background that I'm excited to share all about with the audience, so we'll jump right in. Jesse, can you share a little bit about your background and the journey that led you to your current role, which is president at SML, Consulting Structural and Forensic Engineers? What sparked your interest in AI, and as well as your involvement in both the structural and forensic engineering fields?
I have always been a huge science and tech guy, but I wasn't sure where I wanted to go in my career. And after trying a couple other things, including being a physicist, I decided to go and get a BS in mechanical engineering, and I got that from Cal Poly Pomona in 2001. I worked in the track field for a while because when I graduated from college, 9/11 happened and I couldn't get into aerospace. It was shut down. So I had been doing drafting for a civil structural engineer in college, and I went ahead and got a job at building track homes. And in 2006, I got a PE. I joined SML in 2007 after a short stint at Orbital Sciences as a mechanical test engineer, doing testing on like rocket parts and things. Then I became an associate after working here for a few years in 2012. That was a stipulation that I get an SE. So in 2014, I finally passed that dang test. It was a tough one, but I got through it. In 2000, I became partner here. 2003, I became vice president, and then in 2024, last year, I became president. And so that was the first time I actually had a chance, even though I had thought about a lot of, applications for technology. No one had ever paid me to kind of apply the technology. So I had kind of done a little dabbling here and there with automation and stuff, but nothing major. But it wasn't until I became president that I had the resources available. I could tell employees, do this thing, right? I have an idea. Let's make it happen. And so I was able to actually really get some balls rolling and make things actually start to happen. So that was what really set it all in motion, but it kind of really started well before that.
Absolutely. So, and then now I think you've honed that curiosity about the intersection of technology and then like civil structural forensic, the industry that we're both in. So you've been really involved with the NCSEA AI grant team, and you'll be presenting at both the pre-conference and closing keynote at the upcoming summit in New York, which is October 14th through 17th, right?
That sounds correct, yes.
Yep. So that's in Manhattan in New York. You've also recently joined the NSF IUCRC VISER Center, which we'll go into the full acronym or the full name in a second here. Center, which is focused on AI and structural engineering. So can you just give us a little bit of background on what all those letters mean? And then can you share how those experiences are shaping your perspective on the role of AI in the future of structural engineering and then project delivery?
Yeah, it kind of started with a post on Reddit. About 2 years ago, I met a guy through my wife. My wife is the admin director here, and she was on Reddit looking at the structural engineering forum, and this guy was looking for a summer internship. And she said, there's this PhD student at the University of Houston. He says he's in the SAIL laboratory program or something like that, right? And SAIL was the Structural Engineering and Artificial Intelligence Lab out of the University of Houston. I was like really intrigued by that. And he had done some like NASA projects and stuff using satellite imagery and all this. And so it kind of had this conversation with him about becoming a summer intern here. So I offered him probably more than I'd normally offer somebody, just because I was like really fascinated by his experience with NASA. And he did a great job. He did like 3 projects where he created this tool that we could find old projects that we had done. Through the last few years, we had all of the original owners of SML retire. And so they had been these forensics guys, and they did a ton of forensics reports. But because they were all gone, we had no way to access them, really. Like, we didn't know where to look. So he created this tool that took all the Word documents and compressed them into JSON files and vectorized them so that we could then search through them to find stuff using keyword searches. And so we could look that stuff up. So that was one thing he did for us. He did a couple other things. But anyway, later on, he had invited me to the University of Houston to go and try to create a new center for structural engineering and artificial intelligence through the National Science Foundation, NSF. So VISER is the Structural Engineering Artificial Intelligence Center name that they're trying to make. And IUCRC is the name that is given by the National Science Foundation for these centers. So it's like a program. So like the pharmaceutical industry has a program. They have a center. ASU here is like a part of, I think, 6 or 7 different centers, right? Different ones, not the structural engineering one, but different ones. So the University of Houston was teaming up with Purdue University, NSF, and they're trying to get like, I think 6 to 10 different industry leaders to come in and invest in this center. And if we get it opened, then it would pool our resources to create R&D work. Like the universities would do all the R&D work. The university would put in like 200,000. NSF would put in 300,000. All of these companies would put in like 75,000. And you pull your resources, and now all of a sudden you have like $1.3 million invested in the research and development. And at the end of 1 year, you get all of the things that they produce. And because you're on the board, you get to kind of determine what programs they research and develop. So you get to kind of a say on what that outcome is. And so that really helped me. Well, I should say that got me in this door into this area that introduced me to John Michael, and Shing was there also, and he's on the NCSEA AI grant team. And I had been watching some of the webinars that they've been putting on, so I was really interested with it, and I started talking to him, and next thing you know, he's like, you're a really small business. Almost everybody on this grant team has really big businesses, and they come from one perspective. And we're really looking for a small business perspective because most of the people at our webinars are for small and medium-sized businesses. And we wanted to, speak to them like more, and kind of intrigue them and teach them how to do this stuff and make sure that they understand that you don't have to have, huge companies to invest in AI and technology. So that's kind of where that all led and how I got involved in that. And that I think that, AI and process automation is really the future of many fields, but engineering is going to be one of them. And there's kind of this saying now that, you know, will AI replace SEs or structural engineers? And really the answer isn't that question. It's the structural engineers who leverage AI and automation technology will replace structural engineers that don't. Because if you don't, it's just you're going to be kind of left in the dust because it will really make your processes that much more streamlined.
Transform your technical experts into impactful leaders with EMI's Engineering Leadership Accelerator. Tailored for AEC professionals, this program enhances communication, delegation, and decision-making skills. Flexible, interactive, and designed to fit your team's schedule. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on corporate training.
And it really is amazing, Jesse, because you go from a Reddit post to finding this gentleman who then leads you on this path today where you are now. So from the VISER Center between, Houston and Purdue, correct me if I'm wrong on any of this, individual firm invests about $75,000, but they get the leverage of a total of investment of somewhere over $1 million, which is really useful because you're pooling together all of this talent and money to do what would otherwise be, speaking of these small and medium-sized firms, right? Probably impossible to pull together that level of resources, which then got.
Yeah, and you don't have to necessarily, if you don't want to do a full share, you could do a half share. And so instead of 75,000, you could do whatever half of that is, and you could get a half a vote. So, it still does speak to the small and medium-sized businesses, if you can pull that kind of resource, but get $1.something million of R&D research, I think there's a lot of bang for the buck, right? I think it is valuable, and some way, I know you have a question later about how to, smaller and medium-sized businesses really get into this and not be shied away from the big cost, price point. That is possibly one way. So if they're interested, I'd love to get them involved. We're still trying to get enough. I think we need 2 more investors to make it work. So we really are still looking for a couple more small businesses to or medium or large, honestly, to invest in this.
And I think, and that's naturally on the mind of many structural engineers, and I don't have any stats to back this up, but if it follows the trend of construction, right, like it's, like 80% of the value produced in construction is like firms of like 10 or less people, something along those lines, right? And we know, how many structural engineering firms do you run into that are, 1, 2, 5, 10-person shops? And that's where a lot of this interest is coming from. And it's really great to be able to get your message out there saying, yes, it can be done.
Yeah, I agree. I even started a small engineering firm. It was just me, and I did my own drafting and all this stuff. I ended up not succeeding, but it was mostly just because of not having the synergy. It's very difficult. You kind of really need, some drafters and some other people to really make that synergy. And then even an admin staff that can do all these things that honestly take up way too much time for the engineer. The engineer should be doing engineering. And that's what kind of brought me to the tech AI focus was, how do you get engineers to do more engineering? Doing some of the processes that you can automate where like you're putting addresses and job numbers on all these different things. If you can automate that so that it flows through without you having to type that in, and you can spend more time doing engineering and add value to your client rather than spending all your time just, shuffling paper and making sure the file names are correct. It's like a little silly.
Yeah. And that actually is a great lead into our next question. So two examples you've talked about so far. So parsing different forensic engineering reports for keywords to be able to, as a colleague of mine says, right, like it's almost like Lazarus, like you bring them back from the dead.
Yeah.
So you can actually use them. The second example being these workflows that pull from, let's say, like the kind of the brain of your firm, populate title blocks, headers, right, all the rote and repetitive things that just need to be done. And the other examples that you guys can mention regarding innovation or AI that you're applying in practice?
Yeah, there was a gentleman that left here and there was a big account that he was managing. And when I got a hold of it, what I realized was that the process was fully manual and it took maybe 8 to 10 hours to do the project and another 1 to 2 hours to check it. And I saw that the client was one that had a very repeat process. Like the product was the same nearly every time. The only thing that was really changing was the loads, right? So they had a geometry. It was nearly the same. They had like 4 different products. So we just had to create a tool for each one. But it was basically the same tool. It was just like slightly different models. So we learned that RISA 3D could export the model into Excel. And we're like, oh, well, that's really cool because I know that MathCAD can write and read to Excel files. So if we're able to export the entire model into Excel, and then we could create all the new loads in MathCAD and overwrite those loads in Excel and then create the new model directly out of that, we won't have to hand input any of those loads anymore. They would just kind of build the new model every time. And then we learned that MathCAD can read the reports. It's a list report right out of RISA. So we took RISA 3D list reports and put them into a matrix form and was able to read that directly right into MathCAD. We had most of them already created for all of the checks for all the connections and everything, but we kind of wrote a couple more, got them all in there so that we could actually connect the output directly from RISA into MathCAD. And now that process flow happened with a Shift F9 or Control F9 or something like that, right? Right to Excel, upload that and create the new RISA, download that back in, double check all the stuff. If you have to upgrade a couple things, it's like a quick toggle. And next thing you know, the whole process was very automated. And also I added value to the client because instead of generalizing the outcome, these 13 load cases and converting them into one moment, one shear and one tension or whatever, I was able to look at each load case individually in MathCAD so I could optimize the systems. We also leveraged Hilti because you could take the output. I did a little bit of conversion in Excel, but I could then import all those load cases, LRFD, right into Hilti, and it could do an FEA analysis of the column weld to the base plate, the stiffener plates, the anchor bolts, all of that, like 6 calcs in one, bam, done. We were doing hand calcs on those welds, and we weren't considering the stiffeners as like we should. So the base plate thickness went down by like 1/4 inch. The anchor bolts went down by nearly 1/4 to 1/4 inch. We really saved the client a lot of money by just doing a more thorough analysis, but this process was required to do that. Otherwise, it would have taken even more time. And could you imagine? It was already taking 8 to 10 hours. If we would have tried to process by hand every one of those load cases, it would have taken forever.
And that is a recurring theme I hear, Jesse, where one is the interoperability piece, because we know if you're trying to manually place loads from one system to another, we're subject to human error. That's just the nature of the beast. But it's the same type of like administrative work that's time consuming. It is not really at the heart of engineering, although it's adjacent, so we just do what we got to do. The second part is then, so it'd be design optimization, because because we have a limited fee, we have a limited schedule, we make these assumptions, and then when you start to pile them on top of each other, right, like, and maybe you even have an example of like what let's say the capacity of a specific element was from the process that you picked up after this gentleman left, to now after you've optimized the design, like what percentage in, material, let's say, that you've saved for a specific element. All to say, it's a net benefit to the client because, they're spending less on construction because you're able to hone in on exactly what they need.
Oh, and shipping too. It was amazing. We're doing 20 of these vacuum canopies per project, and they're shipping them from Wyoming all the way across the country, and we even optimized their anchor bolts so that we could actually source those locally by doing all threads, and instead of these heavy custom made heavy hex heads and stuff that they were building and shipping all around the country. It's amazing how much steel weighs and how much shipping costs are. So being able to reduce any weight when it comes to steel is a big impact on your clients. And so they were really happy with that.
Well, if you have the tickets from those trucks, right, you could even do a little case study. How much, this one project, weighed and cost to ship in pounds. And another similar project after you've optimized the design, right? And that's what clients care about. And you hear talk about, structural engineering and a race to the bottom with fees, but it sounds like you guys have a business model, enabled by technology that you can actually show the ROI that your clients are getting by working with you.
I think it became obvious within about 6 months of kind of starting this process and talking to them about the different functionality that we're able to implement and the future of where we're going, it also allowed us to spend more time value engineering other aspects. They asked us to, look at the hole configuration in the column. Let's change it. Instead of square holes, let's go to these oblong round holes. We did some FEA analysis and we're like, it's about a 50% decrease in stresses just by going from a square hole to an oblong hole, around that corner. And suddenly the stress there, because these torsions on here were pretty high. These canopy structures are kind of under tension laterally, in addition to like lateral wind loads because they're cantilevered. So it did end up playing a pretty big role in the design of the columns. And so just being able to optimize that and having more time to spend on those types of projects for them was helpful.
And this again is another good lead into our next question. So then how do you see generative design, machine learning, and other emerging technologies changing structural engineering workflows? How can leaders help their teams adapt to these shifts? And then I'd also like your opinion, right, on the differences between automation and things that we've been doing up to this point, and then now some of these emerging technologies, particularly AI, that we have access to.
I think that there's a lot of value in early stage design development. So I think that the models could potentially help you look at a kind of a preliminary level, maybe multiple avenues you could run down very quickly rather than just say, oh, I'm just going to guess. And like, this is the approach I'm going to take. So there's a lot of feasibility studies you can do very early on using generative design and machine learning that I think will help to optimize the structural down the road and help with the aesthetics they're looking for. Also, it seems like the architects are going with very organic designs that are difficult to design, kind of like if every single column looks like a tree and the branches are not uniform, it becomes a little bit more difficult to design. So I think with these modeling approaches, that will actually be a less conservative design. You can actually take that into account. The organic world has built structures for a really long time, and we've been using, kind of replication of the bio world in engineering all the way through time. But more recently, I think it's more readily available through this machine learning process. So I think that would be a couple different ways that would really impact the workflow going forward. I think these applications really help engineers and firms add value to the clients because they can design these multiple possibilities faster, and you could offer this service that you maybe weren't able to do in the past. So you could add value to yourself that way. You can write your proposals differently where you have like a pre-phase and then a second phase so that you can really get that dived into a little bit deeper and figure out which avenue to go with. But when you're really trying to have the leaders shift their team's focus, I think that using AI to help solve the challenges, meaning like if you're trying to write a script to do an automation function, that's where they really shine, right? You want to be able to have full control of your output. So you have this linear thought process of how a calculation is done, and the code has to be followed. You can't have AI, hallucinating on what the code says. That part you have to have dialed in. But if you're creating a process where you're connecting all these dots and the AI is simply helping you create the script files and things to create that process, I think that's really where you want to teach your teams to try to leverage those tools. In addition to, just your standard stuff for proposal writing and things like that. But when it really comes into the design world, I think that's where you're wanting to help with is the automation process, try to get those scripts. There's a tool that I just started using recently, and I know it's a Microsoft 365 tool called Power Automation. And I was able to I have a letter system for a client, and I wanted to start putting site addresses on the letters rather than the letters being generic. So I created this whole line of flow in there that's completely automated where I have them fill out a form with some information on it. It goes in my file system, finds the actual PDF, opens it up, puts the field lines in there, the client name and the client address, flattens that, digitally signs it, and then emails it to the client. And I was having a struggle just doing it on my own. It was pretty straightforward, but at the same time, it was still complicated. And ChatGPT, I think you could use Claude. I think Claude works. Everyone's telling me that that's better for programming, but I was using ChatGPT to help me kind of troubleshoot the scripting to make it work. And that really helped me. I was able to turn something that probably I would never been able to accomplish into a 16-hour, 2-weekend project, and I got it done. And I was able to present it to the client. And hey, in 2 minutes from filling out the form, he had an email with the letter. It found the right letter. Out of 200 letters, it found the right letter and sent it to them with the address and everything on it, digitally sealed too. So it was kind of locked down so they couldn't modify it. Right now, I've had in the last year and a half, my seal stolen, letters rewritten, like people will open them up and change the wording in there and then send it into the city. I've had all sorts of other fraudulent kind of stuff happening to my document. So I'm trying to digitally sign my stuff so that they can't modify it. The city can still comment on it if you don't quote unquote lock it. So most of them will still accept that, but keeping your intellectual property protected, I think, is a major concern going forward, especially with all the technology out there. Anybody can get one of these rewrite PDF tools and they can make any PDF say whatever they want. I mean, I've done that too, and it's not that hard. So ways to protect that. And I think the industry is really going to have to focus on that going forward. I even have international, like people off of Freelancer and Upwork stealing my stuff and then selling it online. And I get contact from the city of Phoenix saying, hey, you're the engineer of record on this project. Here's the city comments. And I'm like, I didn't do that. It's not even on my letterhead. It's on somebody else's letterhead. I mean, it was, I know I kind of deviated here, but it was that technology, it's good and can be used for evil, if you will. So we have to use the tools that are available to us to protect our intellectual property. So security is going to be a major concern moving forward.
And I've even heard like the use of the blockchain for signing and sealing. And as foreign as that can sound, the idea being is that like whenever you see signed and sealed work product, you can trace that back to some origin. And then if it wasn't you whose name is on the seal, then it would become easy to check, easy enough. Because right now, you're right, like, how do you even know until you get looped in and you're just saying, yeah, I did not do that.
Yeah, someone copied an entire set of plans, put a different address name on it, even changed our job number on there, changed the date on the seal, and resubmitted it to a different jurisdiction. And they literally, it got to the point where it was permitted, it was in bid. A contractor contacted us, asking us questions about it, and we're like, what the heck? And we started looking into it, and we figured out what happened. So we're in a little bit of a dispute, a lawsuit over that one. But yeah, we definitely need, and blockchain, I mean, whatever, the cities are really kind of reluctant to change their process. And certain jurisdictions are kind of statewide, like Florida, like it's more or less kind of over a larger area. But Phoenix Valley, we've got, 15 jurisdictions within like a 30-mile radius of here. And while they still have some overlapping codes, there's a lot of, codes that have been amended, or they're whole different code years. They're using different ASC 22 or 722 versus 716. I think there was even one recently that was all the way back to like 710. I mean, so it's a challenge.
Absolutely. And then speaking of lawsuits and disputes, right, the other part of SML's business, right, forensics, investigation, diagnostics, right, because to this point we've spoken more about structural design, whether it be new or existing, but the second part of your business, I think, is different in the way you approach problems. So I'm excited to hear more about this. So from your perspective in the forensic engineering space, then how do you see AI or digital tools influencing investigation, post-event analysis, et cetera, for that half of your business?
I think that there's a lot of good sensors out there, whether or not that be like a laser cloud point, the data collection, even just drone technology using LiDAR or some other stuff to collect the data, right? But now you have this huge data stream coming in, and you have to turn that into a sealed product. So I think the data processing, you're going to need to have, kind of high-powered tools to do that. LLMs, I think, can be either trained locally, or there's a lot of talk within the structural engineering community on trying to come up with maybe a consortium of engineering firms that all get together and say, we're going to share data. We're going to go ahead and figure out some way to be able to, take the client information out of this data so that we're not violating any NDAs and things like that. But we have some base data that we could leverage, right, as a community, so that we can better train these tools for a wide variety of situations. And maybe we have them trained on a few different ones a little bit, hone that in, crack concrete versus, corroded steel or versus, some other things. But you could kind of have these models that are trained to do specific tasks. And so if you're out doing a large concrete, parking structure where you have cracked concrete all over the place because of deterioration and water infiltration and things like that, you could scan them and use these large language models to help identify the trouble areas more quickly and probably more accurately than a human going out there under low light conditions without, on a ladder or something like that, trying to find these things. And you could then create the repair plans more quickly. So I feel like there's a big likelihood that that's where the industry is going to go. And I think that even you're implementing that. My business partners wanting to implement that. So I think it's kind of here. A lot of that ends up being some third-party resources right now, but I think there are other teams that are trying to develop that internally. And I think that what was very interesting is, I know it's a little off topic, but the steel organization now has a new AI that you can go to. I think it's AISC, I believe, .com, Clark or something like that, /Clark. And you can actually, they've kind of got their large language model honed in to where it's closed, and every single steel code is in there, so you can search through it and find the code section. It'll spit back the code section and help you find the equations and stuff really fast, right? Versus you having to dig through the code manual. 360 is a pain to get through. And if it was all in one place like that, so I feel like each industry will probably end up having their own resource like that. But if the engineers can get together and form the data set that we can use to create the large language models for each one of these industries, it will really help as well progress that along.
And a side note to the audience, if you're listening and you are developing something internally, like Jesse discussed, say like a computer vision model for concrete or steel for your investigations, and that's something you want to speak to, please reach out to me. We'd be thrilled to have you on as a guest. But to the point of AIC, I think they advertised it at one point, right? And it's like a softball, right? AISC, of course. So that's I thought that was pretty clever. And I think NCSEA also has something similar where you can search, I think, the archives of structure.
Yeah, the Structure magazine, I think, right? So it's a little bit limited, but it still has another pool of knowledge that you can search through very fast, which is kind of the key. Finding the information is very tough. Even we're kind of developing a tool right now where you have a ton of details. And how many times have you searched for that detail that you did like a year or so ago for this project, and you can't seem to find it because you can't remember the job number or you can't remember whatever. And so we're creating this tool right now that will take these really large drawing files that have 100+ details in it. Instead of having to search through them all, it takes each detail, it puts it into its own DXF file, creates a JSON file that has descriptions of every single note and kind of like dimensions and things like that. And you can search them so that you can actually retrieve details. So it creates the database, and now I can actually use kind of like a chat window to actually search for the details. And we're just about having that implemented. The last step that we're setting up now is that we're creating MathCAD output that will be the search kind of a line, right? So whatever the output is will actually become the search function that then finds the detail that goes with the calculation and retrieve it and pop it into the drawing. And so I think that could be one way to really leverage stuff you already have, right? You already have all these drawings. How do you find the drawings more quickly? I think that these tools will be what we're going to need to leverage to find that stuff that you already have on file, instead of redrawing it every time, having to QC, QA all those notes again and again and again. You establish it once, make it retrievable, use it over and over, right? I think the more you do that, the more value you can add to yourself and your clients.
search and retrieval, another big one. And there is commercial software out there that will do some of these types of tasks. I think another discussion that every firm needs to have is, do you buy it off the shelf and live with the limitations, or do you try to build it internally to whatever spec you're trying to build it to, right? And I mean, building is, like you said, it's becoming easier over time. You just have to think, do you want to then build it and have to manage it and roll it out to the enterprise and so on and so forth? So that's another interesting discussion that's going on in the industry.
Yeah, I believe that's a big question. And I think that's where your next question kind of actually leads into, because, and if you want to state that question, then I can go ahead and kind of answer that.
Yeah, which is, so a lot of firms are still hesitant to adopt, forget about AI, right? Just digital workflows.
Yeah.
Then you start to add AI, machine learning, computer vision, everything that goes along with it. And what do you think are the biggest mindset or organizational hurdles that AEC leaders need to overcome when they're considering the types of things we're talking about?
Primarily, that ends up being the cost factor. It sounds like it's going to cost a lot, and in some cases it can. You have these huge organizations creating these huge models, and they're talking about, I spent $1 billion. Or, okay, well, that's obviously outside most people's budgets. So they're like, I don't want to do that. And then they're also trying to figure out, how do you get a return on investment for this? Is it going to actually pan out? They want to know that it's going to work, which me too, right? You want to know before you get in there. Even before I write a proposals, I often want to know that I know the answer to all of the calculations before I write the proposal. That way I know I can stay in budget. So the ROI is a big concern. They're worried it's not going to be enough to overcome the costs. And then there's legal risks. You don't want to have AI hallucinating on something and you having to go in front of your board of technical registration to try to justify this design that maybe you didn't do. So you want to keep the AI doing things that, are verifiable. More the process, at least at this point. I think maybe that'll change over time, but at the immediate situation, I believe that if you're still handling the actual calculation flow and you're having it help you get all of that done, like the scripting to make it automated and flow, then you're kind of taking that legal risk out. So how we kind of helped to minimize the cost was we hired an intern at a local university that was a data scientist, and he also had Python coding knowledge. And so he was able to come in here, part-time. I have 25 people here. We're a $5 million firm, right? So we're not huge. We're in that small to medium, I'm not even sure we're medium at this point, size business. And we don't have a big fund, right? But we were able to leverage internships to do it like part-time. And if you can just have the idea and you can, assign the task to somebody. And that was the big thing. Once I became president, it was like, I can now assign people a task. Do this thing. I have a vision. Let's make it work. Okay, here you go. You're going to spend a week on this. And then like 2 days later, they come back and like, I got it half done already. And you're like, oh my gosh, wow, it's amazing. I wish I had a whole, 16 hours straight to work on something. I wish my boss would have told me to do that. The other thing that we did was kind of negotiated with a client to, they wanted a process done. They wanted somebody hired right away to do it. We tried to get the intern to do it, but he just wasn't able to put enough time and resources into it. So we were able to get a professional out person to do the job. If you're not wanting to spend local prices, then there are other options. You can do international. There are a lot of international people out there that know programming very well that will do it at a lower rate. So we hired a couple people through an organization called TopTall, and in 48 hours, each time we did it, we had a pro ready to work. So it took very little time. I didn't have to try to find these people. I was in an area that it wasn't my first expertise, right? It's more like a side hustle, if you will. Like, I'm a structural engineer. I don't know about front end and back end and full stack. And what does that even mean? But TopTall knows all that stuff. So they know how to get you what you need. And they were able to find me the resources. And again, they were at a cheaper price point. So that helped me get in the door, bringing my costs down. So both of those options could be something you do. There's also a lot of engineers coming out of school that have more programming knowledge. So maybe hire some people that actually do. They have engineering and some programming. I, as a structural engineer, am mechanical. So I saw the value of actually hiring mechanical engineers. Do they know ASC code? No, but they know how to do some programming. They know how to do math really well. They have a very good background in science and stuff. So even though I have a lot of PE civils here, I also have 2 other mechanical engineers working for me doing a lot of innovation work with this. So maybe hire outside the structural engineering, get some mechanicals or somebody else that might have this kind of cross knowledge that will help you bridge that divide. As far as return on investment, I think if you were to take kind of small steps, build incrementally with systems you already know and use, rather than starting with systems that you have never heard of before. Maybe you already know a lot about Excel. You've been kind of developing stuff in Excel for a really long time. The really nice thing about Excel is that it will communicate with a lot of other engineering software. You might not realize it, but it'll communicate with MathCAD, EnterCalc, RISA 3D, AutoCAD, and of course itself. But those are some software that I was already using. So I now use EnterCalc as kind of a center point to talk to all of those different programs so that I don't have to move data back and forth. So something simple like that can use stuff you already know for the most part. You just have to kind of figure out the little bridges that connect the dots together. If you want to go one step further and you have maybe an online cloud tool that is used as your central database for your clients and projects, I use BQE Core, and it has my client information, project, billing, CRMs. It has everything in there, and it has an API access. So I can come in the back door, take that output, go into my Excel file. Once I have it in my Excel file, now I'm talking to AutoCAD. I'm talking to all those things that I told you about. But I have one central place where I put my project information, and now Excel's reading it right out of there. It then populates my other programs. So I don't have to have repeat information anywhere. I don't have to check the address 1,000 times. I just put it in the one time. It populates all my things. I don't really have to keep track of that anymore. So those are some ways to kind of get your foot in the door, start getting a return on investment sooner rather than later, using tools you already know rather than talking about a bunch of stuff you don't. So I believe that those are kind of the hurdles, or how you can get your team getting over those hurdles.
I love it. And you're starting relatively simply, but I think more importantly, like you said, you're not trying to bring new software or technology in the door and train all your people. You're just building off what you already have as existing, which I think is fantastic, because there's a lot less problems that come. I think as long as the processes are solid, there's a lot less headache managing less change.
You already have templates built in MathCAD and Excel and some of these other RISA 3D models that you've been doing for years. You know that those are already tested. So how do you just connect them together?
Excellent. Jesse, the final question I'll have for you today, one final piece of advice you'd like to share with engineering and technology leaders that are trying to figure out how their business is going to look in the future as this wave of change just kind of keeps coming at the industry.
So I kind of thought back recently to about 20 years ago when I first realized I was working for somebody else, and I realized that Excel and AutoCAD were both a Visual Basic background, right? So they're both, built on Visual Basic. And I was like, it really seems like they could talk to each other. It really seems like you could draw something in AutoCAD, export it to into Excel, and it could run a calc for you based on like, okay, I put this line on the roof layer, and when I import it into Excel, it knows that roof layer means a 20 dead and a 20 live. It told you the 2 endpoints, so you know what the length is, and you could actually run a beam calc off of it just by an import-export process. But I couldn't convince my boss at the time to kind of like pay me to like implement this process. And so we were in track homes, and it was like, go, 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 right? So there was no time to develop these things. But had I started doing that then, 20 years ago, I would have been a lot further along. So my advice is start now. It's almost like investing. You can't get a return on investment until you start investing. So you have to start now. Mm-hmm. You start small. Doesn't matter what you're doing. Like my grandpa used to tell me, just start putting a penny away every day. Whatever it is, just start doing something. So do a small thing now. It will reap big rewards later. But don't expect a miracle. I think that's the one thing with these. Like I was debugging that process, that automation process, and it can be pretty frustrating at times. It's not working. It's working. All of a sudden it works and you realize, oh, it's all there finally, right? So it might take you a little while. So don't expect a miracle. You'll get stuck along the way, but a lot of people that succeed in this world have failed many more times. So you have to fail to succeed sometimes. And I think that that's the key to this, is you just keep making progress a little at a time, but start now, and it'll, you'll be at a year from now and all of a sudden you have something. And if you didn't start, you wouldn't have anything.
Yep. Time is, and the more this world, moves in the direction of everything we've discussed today, the more I figure these principles are timeless, right? Start simple, start now. Don't get frustrated because things inevitably won't work as planned the first time. But Jesse, thank you again for taking the time to join us today. If the listeners want to connect with you, ask questions about anything we've discussed, learn more about your workflows, what's the best way for them to reach you?
We could probably go to LinkedIn, Jesse Light, SML, and LinkedIn's pretty easy. I can give you my email, jlight, JLIGHT, at SML, like small, medium, large, ENG, like engineering.com. I can reach out directly. I'd be happy to kind of work with you to try to get you up and running on this sort of thing. But structural engineers that want to come out to the summit in New York, they'll be talking about all this stuff in way more depth. I'm kind of more of a user than a developer. I still do some development, right? But they have developer tracks, they have user tracks there, depending on where you're at. You could even have yourself on one track and have some of your teammates on the other track. Those are some places you can really start to get the fundamentals. They're trying to now, they developed an idea, now they're trying to implement it. So, get involved with that sort of thing. But you can reach me at my email or through LinkedIn. Those are pretty easy places to find me.
Jesse, thank you again. It's been an absolute pleasure.
Thank you so much. Appreciate being here.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.